Hello friends, today we are going to deal with one of the example of single source shortest path algorithm. So the graph is represented here in the form of cost adjacency matrix. We require to solve the single source shortest path using source vertex as A. So initially on the first initial step we require to construct a cost adjacency matrix. So the cost adjacency matrix is represented as follows. So first of all there are 5 vertices as in the graph. So first A to A I will represent it with the help of 0, A to B 5, A to C as there is no direct path, so I will represent it with the help of infinity, A to D 6, A to E infinity. So in the similar context you require to have the values of B, C, D, E vertex. So the final adjacency graph is shown in the figure. So now moving to the next step, we require to construct a path and the distance array. So the path array should be filled with the source vertex. So initially P of A is A, B is A, C is A, D is A, E is A. So we are having one more, that is distance array. So this distance array we can fill it with the help of cost adjacency matrix. As our source node is A, so I will fill the values of distance from the source vertex A, that is distance to A is 0, B is 5, C is infinity, D is 6, E is infinity. So now to moving to the next step, we are required to take the help of tabular form to solve this particular problem. So this tabular form consists of 5 columns where S represents first column, that is your source vertex. V minus S represents remaining vertex, that is your second column. So third column consists of the distance of V we require to calculate, which is equal to minimum distance of V comma distance of U plus cost of UV. The fourth column consists of a path value, that is P of V equal to U. The fifth column we require to find U and D of U such that D of U is minimum. Now moving on to our first step. So as our source vertex is A, let me consider the source vertex as A. So the remaining vertices are B, C, D and E. So now we can have a distance of B, C, D, E from the distance array which we have already computed earlier. So similar context we require to even go for the path. So P of A will be A, B will be A, C will be A, D will be A, E will be A, as we can get this value directly from the path array. So the fifth column we require to find U and D of U such that D of U is minimum. Now among the remaining vertices B, C, D, E, so the distance of B, C, D, E as we are having, we need to find among all which one is minimum. So I find in this context the distance of B is 5, which is the least value. So I will now consider U as B. Now D of B will be equal to 5. So B comma 5 will be the value which is obtained at the last column of your first step. Now I will consider in the next step B as my source vertex. Now the remaining vertices are C, D and E. Now we require to compute the distance value of C, D and E from B. Now D of C is equal to minimum D of C comma D of B plus cost of B comma C. So use that formula which is in the table 3. So on applying this one, we are getting here minimum D of C we require to take it from the earlier step, so that is infinity. D of V we calculated again in the earlier step, that is 5 plus cost of B to C I will take it from the cost adjacency matrix. So once I find it minimum infinity comma 6, so I find that 6 is the minimum value. So in the similar way, I will calculate d of d is equal to minimum d of d comma d of b plus cost of b to d. So minimum, earlier d of d value is 6 comma d of b is 5 plus I can call the b to d is definitely, I will take again the help of cost adjacency matrix. So I will take here the value is 3. So between 6 and 8 I find that 6 is the least value. Now next value is d of e, minimum d of e comma d of b plus b to e. So minimum infinity comma 5 plus infinity. So the value will be infinity itself. Now as we computed the distance of C, D and E, you require to check with the previous step. So you are required to check whether the distance to C is changed, D is changed, E is changed. So I find that distance to C, earlier it was infinity. Now in the step 2, what you find is it is 6. Now d of d in the earlier step was 6. Now presently again 6. D of E, earlier it was infinity, now also infinity. Among C, D and E, you find that the distance value of C is changed from the earlier step. So we require to change the path value of C only. So the path value of C will be your new vertex, that will be your B. So the rest all the value of your path will remain same. That is P of A is A, P of B is A, P of C is B, P of D is A, P of E is A. Now next we need to compute U comma D of U. Now how to compute this one value? Among the remaining vertices C, D and E, so you computed the distance value. So you find that C and D are the least value. Now there is a tie between C and D. So you are required to initiate one step, that is the one which comes the in alphabetical order first, take that value. So I will take here the C as U, my next U, comma D of C value will be definitely equal to 6. So now in the third step I will consider C as my source vertex. Now I need to again compute the distance of D and E, which are remaining vertexes. So the distance of D and E is computed as in step 2. As we did in similar context, we need to compute the value of D and E as we did in step 2. So once you do it, you check the value of D and C. Now check with the previous step and the present step. D of D, earlier it was 6, now it is also 6. In the same context, you check D of E, so it is infinity, now it is changed to 12. So as I said, the D of E is equal to 12, which is changed from infinity to 12. So the path with respect to E will change to the new source, that is your C. So P of E will be equal to what? C. The rest all, the path value will remain same from the earlier step. P of A is A, P of B is A, P of C is B, P of D is A, P of E is C. Now I need to find again U comma D of U. So I will check now between distance D and E, one which is minimum. So I found that D is the vertex which is giving you the least distance value. So I will take D comma 6 as the U comma and D of U in the third step. So in the fourth step, I will consider D as my source node. What are the remaining vertices? Now I find in the fourth step that E is the only remaining vertices. So I need to compute the distance value of E. So compute the distance value of E as we have computed in step 3 and 2. So what you find is earlier distance value of E was 12. In the step 4 it has changed to 8. Now in the same way as the distance changes, you require to change the path also. Means what? P of E will now change to D. The P of E should be changed to D. Now what will happen? P of A is A, P of B is A, P of C is B, P of D is A, P of E is D. Now the next node is definitely the last node which is left out, e comma 8 will be the value. So now I will consider e as my source vertex. What I found is I don't have remaining vertex to be visited, so I will not compute the distance value. I will not go for path, and I will not able to find u comma d of u. So the last step is over. Now how to construct this graph? To construct this graph, we need to take the help of the path value which we obtained at, I can call it as step 4. So p of b equal to a. So I need to form an edge between a to b. In the same way, p of c is equal to b. Form an edge between b to c. Again, p of d is equal to a. Form an edge between a and d. Again, you check down once again, p of e is equal to d. Form an edge between d to e. Now, if you check the values with respect to the last column, you will find the result of your graph. So, to reach from a to c, it is taking 6 value, 6 as the cost. Now, you just check your second step, c comma 6. So, the cost is same. So whatever we have solved this problem, what I find here is the shortest path from source A to all other nodes. So this is how we need to compute the graph and solve this problem. I hope you have understood this problem. Thank you one and all for watching this particular video. Have a nice day ahead. Please like and subscribe the channel for more updates. Thank you one and all.